Hey guys, welcome back. Day 16. We're going to talk about types of bonding and how to name chemical compounds. So let's dive right in and talk about first what is a chemical bond. So we got to define a chemical bond, of course, and this would be the sharing or transfer of usually its valence electrons to attain stable electron configurations for the bonding atoms. Right? All right, the key word there is isoelectronic. We want to be isoelectronic, of course, with a noble gas. So what are the types of bondings? Well, the one we will not do is metallic. And these were metals, which would mean they are below or left of the stairs. And they have what we call a delocalization of the electrons. So the electrons are not necessarily per metal. It's kind of an electron sea, so to speak. Then we have ionic. And this would be a metal plus a non-metal. Right? And we are opposite sides of the table, of the stairs. All right, far apart on the table. And these are a transfer of electrons. Electrons are transferred. And then we have molecular or covalent. And these would be nonmetals. This would be above the stairs. And hydrogen. And we are sharing electrons. So how they're put together are different. So metals are non-directional a lot of times, right? This is how we can do malleable, where you can hit some metals and you can spread them out because they're still bonded, but it's not a specific direction. So it doesn't have to be always exactly, let's say north, south, east, and west. All right, because we haven't talked about shapes yet. Ionic is a transfer, and so you just have a lattice of alternating positive and negative, positive and negative, positive and negative in 3 dimensions. Where molecular, you have small, discrete units bonded together. Like water, H2O is 1 H or 1 O and 2 H's. 2 H's, 1 O. That's it. There is no, and you just have a collection of these H2Os, these individual things. Okay, so now if the molecule, so a molecule, which we just talked about there, is a particle composed of 2 or more atoms chemically bonded. So a molecule, again, is a particle composed of 2 or more atoms chemically bonded. If the atoms are the same, the molecule is an element. If the atoms are different, the molecule is a compound. So we have O. We have an atom. O. So this would be the oxygen atom. O2. O3. So what's O2? O2 is oxygen gas. Right? It's a molecule and an element. Ozone. It's a different allotrope of oxygen. So it's another way the element comes. It's not its standard way. It's a molecule and an element. Okay, versus if I have N2O, NO, and O2, right? These are all molecular compounds, right? Those are all compounds because there's nitrogen and oxygen there. So when we talk about compounds, we're pretty much going to talk about binary compounds. So you know it's binary. So binary compounds are two different atoms or ions bonded together. Okay, so when we talk about naming binary compounds, we'll name molecular binary compounds first. So what do? If we have a periodic table here, that's my periodic table. It's this way, first to last. Looks somewhat like that. Okay, that's my periodic table. So in general, we write the name of the element to the lower left first, then the name of the second element changing the ending to "-ide". Okay, and so technically there is an IUPAC order. And that would be C, P, N, H, S, I, B, R, C, L, O, and F. So that's technically the order of the atoms and compounds. Now, you'll see it. Ooh, I don't need a comma there. We'll see it. Sometimes you'll see it, BrO3 minus. But sometimes you might see it OBr or OCl. Like, it doesn't, like, if you write it the wrong way, it's not necessarily fatal to your communication. Sometimes it depends on how you write it, because a lot of times we'll learn, once we learn how to bond these things, which we'll do soon, relatively soon, the next chapter, I believe we'll do it soon, is that once we learn how to bond them, sometimes we write them how they're bonded versus the IUPAC order, because it, as you can imagine, as these Lewis structures get bigger and bigger, as these shapes get bigger and bigger, sometimes there's more than one way to put them together. And if there's more than one way to put them together, how do I put them together? Sometimes our chemical formula gives us a lot of information on how to put these things together. So that's not always in the IUPAC order. That being said, most of the binary ones will be. Okay, so when we are naming these, we will use prefixes to indicate the number of atoms in the molecule. And so a lot of us know some of these prefixes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a lot of these we know. Mono, di, tri, penta. I'm sorry, not penta. Penta's 5. tetra, penta, hexa. This one, hepta, is the one that a lot of us are familiar with. Octa. Nona is also not. I'm putting N-A. Nona, N-O-N-A. Nona, it's a different language. And then deca. So a lot of these we've heard of. Okay, a lot of these we've heard of. Two notes. Note. The prefix mono is dropped for the first element, which kind of makes sense, because if I say carbon, you know there's one carbon. Carbon dioxide, carbon monoxide. There's one carbon. Because I have to say it, just like we say 1x. No, we don't say 1x. We say 3x, but we don't say 1x. Why? Because if I say x, you know there's 1x, or 1y, or 1z. So it's the same principle here with the mono. The other note, and this one's more important to focus on because it won't be as natural as the dropping mono, is that the general number of hydrogens, right? Hydrogen atoms, H atoms, is not denoted by a prefix. That means we just kind of have to know how many hydrogens are there. Well, pretty soon it'll be obvious why. All right? And so I'll do this now for us. If you look at the groups, you have group 13, group 14, 15, 16, 17, 18. Right, group 13, right, I'll just use the first element of each: B, C, N, O, F. Then we got N, E. So group 2. Sorry, period 2, groups 13 through 18. So how many H's? Well, it would be H3, right? So it's X, H3. Then we have XH4, XH3, H2X, HX, and nothing. So group 13 is pretty much going to have 3, like that's what they prefer. Hopefully that makes sense. This is preferred. Let me write that down. That doesn't mean it's going to, they get what they prefer. But that's the preferred number of hydrogens per the column. And this will make a lot more sense once we draw the Lewis structures and you see the patterns. Okay. Some molecules have common names. H2O, NH3, CH4, PH3. So of course H2O would be water. Ammonia is NH3. Methane, CH4. And phosphine is pH3. So some quick examples. Start easy. CO2. Then we have N2O4. And then we have OF2. SCl4. I'll have PCl4. Cl5, H2S, Ni3. All right, CO2 would be carbon, dioxide, carbon dioxide. Now we're going to get to, and right here will be example for N2O4, dinitrogen, because there's two N's, tetra oxide. Now, I'm going to highlight this. A lot of times that A is dropped. Sometimes we drop a vowel and sometimes we don't. That is a very, very minor detail to me. Why is that a minor detail? Because if you have dinitrogen tetraoxide down, you have successfully communicated to me that this is N2O4. That's what I care about. That you have a extra vowel is not going to bother me. The spelling, that's important. That's vital. Obviously, in purple, the prefixes and the endings. The endings are very, very important. Because you have ides, you have eights and ites coming up. And so the ending is very, very important. Okay, and obviously, if you spell nitrogen, right, dinitrogen, if you spell nitrogen C-I-R-B-O-N, that's wrong, right? Because it's not carbon, it's nitrogen. But some of these, like phosphorus, if you mess up a letter in there, not the end of the world, right? It's if you got to have the right prefix, you got to have the right ending. That's very important. And we got to be able to tell what atom it is. So hopefully that clears up any questions on spelling and whatnot. Oxygen, difluoride. Sulfur tetrachloride. Then we have phosphorus. Right, now let's say I spelled it wrong. P-H-O-R-O-S-O-U-S. Well, that's not good. That we wouldn't really get that one. Let's do a little bit better job. Let's say you spelled it like that. Would I mark it right? Probably. Probably. I would probably mark it right. Alright, phosphorus pentachloride. H2S, we just say hydrogen sulfide. Keep my NEs going here. Hydrogen sulfide. Now, if you would write dihydrogen monosulfide, I personally would mark that right. But a lot of times we just call it hydrogen sulfide. And last but not least, nitrogen triiodide. If you notice, we do not drop the I's. So there's no I dropping there. So that would be molecular compounds.